Alright class, so I know I'm not going to be in today again. I have meetings. So what we're going to do is we're going to go through the graphs of polynomials, and basically I really don't care about graphing them. We're not going to do a lot of graphing by hand. If anything, we're going to use our calculators to graph this stuff. But I want to kind of talk about the characteristics of these graphs with polynomials. And when I mean a polynomial, that means a quadratic. It could be a cubic. It could be a degree of 4, degree of 5, 6, 7, 8, 9. And just kind of the characteristics that these polynomials have and its common characteristics with them. So the first one that we're going to work with is a graph that we're used to working with. All right, is y equals x squared plus 2x minus 8. All right, so this is obviously a quadratic. You guys are used to seeing this stuff. All right. If at any point you need to pause the video to be able to take notes and slow down, please just pause the video and go from there. All right, I'm going to do a rough sketch of this. There's a couple points that we're going to be interested in, and it's just a rough picture. All right, we all know that with quadratics, we're really looking for zeros, and we're also looking for that max min point, that vertex. All right, so that's what I'm really interested in right now. Now, since we've already worked with these before, this is the stuff that we're going to try to identify with all of our polynomials. So we're going to look at the degree, how many zeros we have, the type of zeros, and we've already identified some of the stuff before. Types of zeros could be real, there could be double zeros, that's the bounce point, and then there's also imaginaries. We're going to talk about turning points. All a turning point is that within all our polynomials, remember, you read a graph left to right. So say you start reading your graph and you're decreasing, and then it changes to an increase, there's a turning point. That point is where it changes direction. Right? So that's what we're looking for. How many points are there on the picture where we start to change direction? All right, we're going to look at any kind of max or min that the picture might have, the graph might have, and then of course our intervals of increase and our intervals of decrease. Alright, so like I said, if at any point you guys need to pause the video, just pause the video. And then the last thing, we've talked about this before, but it might be new to some of you. You might have forgotten. It's called end behavior. Alright, obviously our degree is going to be the largest exponent that we see. Whenever we see that largest exponent, it's going to tell us how many zeros we're supposed to have. And we already talked about with polynomials, you can have a combination of real, double, and imaginary. Alright, so in this case, since it's a degree 2, we're going to get 2 zeros. And if you look at the picture, we actually have those 2 zeros. There's a real 0 right there, and there's a real 0 right there. So we have 2 real. Remember, when we start to identify the types of zeros, that should be our total amount of zeros. So say we have a total of 4 zeros, I have 2 real, that means I could have 2 imaginary, or I could have 2 real and then 1 double. We got to be able to make sure that we have all those different types of zeros written out there. Alright, now the number of turning points that we only have 1 turning point. I only change direction once. If you look at your picture, you start at the left, you start to decrease, you hit the vertex, you change direction, and then you increase. Alright, with this, we do have a minimum value, and that minimum value is -9. When we increase, remember, we're going to increase from our x value to the right side of our domain. We're decreasing from the left side of our domain to that x value, that changing point. Alright. So when we look at our interval of increase and decrease, read your picture, start at the left side of your domain, which is -infinity. You decrease to that minimum point, that turning point, right down there. That's a turning point. Right? And whenever we identify our intervals of increase and decrease, it's always our x values. When we look for maxes and mins, that's how high the graph is, how low the graph is, those are your y values. Right? Now the last thing is going to be our end behavior, and that's at both extremes. So when I'm on the left side of my graph and when I'm on the right side of my graph. So when my x goes to -infinity, what are these y values doing? And when x goes to positive infinity, what are those y values doing? You can see that both my arrows are going up, so that means my y values just increase constantly. So on both extremes, on both sides, we're increasing, right? So we've done that before. If you need to take a moment to pause the video, go ahead and pause the video so you can write this stuff down. But the next page, I'm going to work with another polynomial, a different one. All right, so this polynomial is going to be y equals 1/5 x cubed minus 3/5 x squared minus 13/5 x plus 3. If at any point you want to graph this and take a look at the picture, you can. I'm once again just going to draw rough pictures up here, just some of the important pieces of information. So when you graph this, we have 3 x-intercepts, and remember another name for an x-intercept is a 0. And then I've got these other 2 points that I'm going to be interested in. And you can find these on your graphing calculator. I've already figured them out. All right, and this is what the picture would look like. Once again, it's a very rough sketch. All right. Now, once you have that drawn, we're going to identify the exact same information. Our degree, our zeros, type of zeros, turning points, I'm just going to label it as TP, max or mins, our increase, our decrease, and then our end behavior. All right, so with this, obviously, once again, you're going to look for your degree. It's a degree of 3, which means we should have 3 zeros. Now, if you can look, you see that we have 3 x-intercepts. We have 3 real zeros. Now, turning points, here's a TP, and there's a TP. We have 2 of them. We change direction twice. Now, when we talk about maxes or mins, technically we don't have a max, technically we don't have a min. And that's because my graph keeps going up forever and it also keeps going down forever. But when we localize it within specific areas, so within this area we have a max, and within this area we have a min. So those turning points actually become our maxes and mins. So the more turning points we have, the more maxes and more mins you're going to have. All right, so we always like to pick the highest of those turning points and the lowest of those turning points. Well, we only have one high turning point and one low turning point. So our max becomes 4.9 and our min becomes negative 4.9. All right. Now when we start going through our increase and decrease, starting out at the left side of my domain, I start to increase, then I decrease, and then I increase again. Okay, so I've got 2 intervals where I'm going to increase, and that's from negative infinity to negative 1.3. Remember, you're going to use your x values. And then from 3.3 to infinity is where I'm increasing. Now, in between these 2 x values, from negative 1.3 to 3.3, that's where I actually decrease. All right, so we identified all this stuff from our picture. The last thing is at my extremes, as x is going to negative infinity and x is going to positive infinity. I want to know what my y values are doing. So if you could see, this is my negative infinity side. It's going down, so my y values are going to go to negative infinity, while on the other extreme, it's going to be going up, so my y values go to positive infinity. All right, so those are 2 polynomials. I'm not going to go through more because it's going to be repeated. When I get to x to the 4th or maybe x to the 5th, you're going to start to see that a lot of this stuff we end up repeating. The main thing that's really going to change is the degree. When the degree changes, obviously the zeros change, and when the zeros change, the degree changes. The turning points are going to change. All the increase and decrease, it's just going to get more and more and more complicated. All right. So once again, you need to pause the video, go ahead and write this stuff down. But I'm going to get moving on. So the next part is there is a relationship between the degree of the polynomial. If you can identify the degree, it can actually give you a ton of information. This is where the bulk of of today's notes is going to come from. Right? We're actually going to go through a decent amount, but this is where we really have to understand what's going on. So the degree of the polynomial. Now we've already discussed this before. So you should be able, this is just something that you're going to be able to figure out. The degree of our polynomial is actually going to help identify a ton of information, and it's always going to be the largest exponent. Okay. So within that degree, the degree helps find the number of zeros. And the degree also identifies the number of turning points. All right, so an example. If our degree is 6, now we know how many zeros we're going to have. That's 6. And then we can identify the number of turning points. Now, if you started to recognize, we had a degree of 2, turning point was 1. Degree of 3, turning points were 2. If I have a degree of 6, my turning points are actually going to 5. It's always going to be 1 less than your degree, right? Because that's how you're going to be changing. You're already going in one direction. You have to change 5 times to finish it up, right? You can't have 6 turning points, otherwise you're going to have a degree of 7. All right, so our degree tells us a lot of information. The degree is also going to help us with our end behavior. Now what we do is we call the extremes of our graph. Now that means as x goes to negative infinity, as x goes to positive infinity. Those are our extremes. So what's happening on the right side of my graph, what's happening on the left side of my graph, right? So that's what we're going to work with next. So once again, take a pause if you need to be able to write this stuff down. But so far, our degree has given us a lot of information. It says, hey, you got this number of zeros, you got this number of turning points, and now we're also going to figure out, well, what's happening at those extremes? What's happening to the right side of my graph? What's happening to the left side of the graph? All right. Now, if the degree is even, which means it's anything that is 2, 4, 6, and so forth, right? The end behavior will be going in the same direction. So, examples. They're either going up to infinity. So on the left side, we're going to infinity, and on the right side, we're going to infinity. Or we're going down. So y goes to negative infinity, and y goes to negative infinity. So remember, that's on the left side of your graph and on the right side. So the domain, as my x value goes to negative infinity, or my x value goes to positive infinity, doesn't matter, my y's are going up, or my y's are going to be going down. Now, in this situation right here, this means my a value, and we've all discussed what the a value does. that means my a value is negative. All right, that means it has been reflected over that x-axis. Remember, our a value does three things. It has the option to do three things. It can stretch, it can compress, or it can flip. It can reflect over the x-axis. It's going to stretch if it's a 2, 3, 4, 5, 6. It's going to compress if it's 1/2, 1/3, 2/3, anything that's going to be less than 1. It's going to flip, it's going to reflect if it's negative. All right, so right now, a value positive, we're both going to positive infinity. Up, my a value is negative, we're both going to negative infinity. So now you should be able to look at a graph, and you should be able to look at an equation, and you should be able to determine, well, what's happening at the extremes, what's happening at the left side of the graph, and what's happening at the right side of the graph, if my degree is even. Now, if the degree is odd, so that's 1, 3, 5, and so forth, the end behavior is going to be going in opposite directions. So an example would be like this. So one side, my y is going to infinity, the other side, it's going to negative infinity. Or we can flip it. The left side will increase while the right side decreases. Now, if that happens, once again, that's my a value. This is where my a value is going to be negative. Now, what that means is that we're reflecting it over a specific point. That would be our origin, or a specific line. That would be y equals x. We are reflecting it not over the x-axis. That's not what's happening. Or actually, no, we are reflecting over the x-axis. How many of you? Forget that. Strike that. All right. The degree is odd. We're going 1, 3, 5. The end behavior will be going in opposite directions. The first one, left side goes down, right side goes up. I'll show this to you in class as well when I come back on Wednesday. All right, but I wanted to give you guys at least a heads up as to how this stuff is actually going to work. All right. But if the left side is going up, the right side goes down, left side going to positive infinity, right side going to negative infinity, that means your a value is negative. It has been reflected. All right. So that's the main thing that we're going to be able to recognize from our degree. Now, the one thing that you always have to remember is that the degree is just going to identify the number of zeros. It's actually not going to identify the type. All right? If you want to identify the type, you're either going to have to graph or you're going to have to do some solving. All right? Now, we've just got through a ton of solving using our synthetic division. Remember, we're really not solving with synthetic division. What we're doing is we're factoring. We're trying to put it into factored form, so then we can actually do some solving. If we have our factors, we can find our x-intercepts and we can find our zeros. All right. The one thing that our degree, if we just look at our equation, it's just going to say, hey, it's degree 6. You have 6 zeros. You cannot identify the type. So if we're going to identify type, we either need to see a picture, the graph, or we need to do some solving. Right? So here's going to be one graph. All right. And right away, I'm going to mark a few important points on this picture. Obviously, you can see I'm trying to mark some x-intercepts, trying to identify some zeros. I also started to mark some max points or some min points. Those are going to be my turning points. All right, so we're still going to identify everything that we've done before. We're going to identify our degree, our zeros, the type that we're working with, the turning points, okay, our end behavior. All right. Now, with this end behavior, we can identify a couple things first. What I'm going to try and do first is I'm going to identify the turning points. If you're not sure about the degree, identify how many times it turns. Here's a turning point. here's a turning point, and here's a turning point. All right, wherever it changes direction. So I started to increase, I hit my turning point, I decreased, I hit another turning point, I increased, I hit another turning point, and I decreased. So I have 3 turning points. Now if I know my turning points, I actually know my degree. So I'll identify my degree, that gives me 4 zeros. All right, I'm a 4th degree, I got 4 zeros. Now what we need to do is identify our type that we're working with. Since we have a picture, we can do that. This is a real, this is a real, this is a double. Remember, we should have 4 zeros, which means combinations of real, imaginary, and double. I have 2 real and 1 double. And we always need to have 4. When I say I have a double zero, it gets counted twice. So if you think about it, I really do have 4 zeros. I just have a repeated value. All right, so we have everything that we need. Last thing, end behavior. As you can see, both sides are going down. It's even. If it's an even degree, end behavior should be going in the same direction. They cannot be going in opposite directions. So we're going in the same direction. So as x goes to positive infinity or negative infinity, it doesn't matter. My y's are always going to decrease. They're going in the same direction. So even degree, end behavior, same direction. It's going down. That means my a value is negative. So if I saw the equation, that's what I'll be working with. Once again, take a pause break if you need to be able to write this stuff down. But I'm going to be moving on to the next example. It's another picture. Once again, I'm going to identify some important pieces of information from the graph. Still going to try and find our degree, our zeros, the type that we're working with, our turning points, and then, of course, our end behavior. Once again, you're looking and you're probably thinking, well, how many zeros does it have? Well, you have to, don't worry about zeros. Look at the turning points. Here's a turning point, it changed direction. Here's another turning point, it changed direction. I increased, I stopped, I started to decrease, I stopped, and I went back to increasing. So I have 2 turning points. If I have 2 turning points, that automatically means I should be a degree of 3, and I should have 3 zeros. Now what you need to do is identify your type of zeros that we have. I have 1 real 0. I don't have any other real zeros. I don't have a double 0. All right, there is no bouncing point where it hits the axis and goes back up. So that means my others are imaginary. And remember, we've talked about this before. Imaginaries have to come in pairs. So that means I have 2 imaginary automatically. All right, so there's my 3 zeros. One of them is an actual real value that I can plot. The other 2, that I can't be able to do that. All right, they're not real actual zeros. They're not real x-intercepts. All right, so we got all that stuff. Now, as you can see, it is an odd degree. Our end behavior should be going in opposite directions. Be careful. Look at the left side. That's my negative infinity for my x values. My y values are decreasing as well. While on my positive side, my y values increase. This means that my a value is positive. It is not negative. If it was negative, we would have been flipping. So negatives go with negatives, positives go with positives. That's a positive a value. All right. When I'm looking at an even, if both of my end behaviors are going up, it's a positive a value, while if they're going down, that would be a negative a value. So this one is a positive a value. All right. So that's just identifying some basic information just from our picture. All right. I'm going to do one more. Hopefully you guys can identify and see what's going on with this stuff. Once again, important points. I'm going to go ahead and plot those. Same idea. Let's figure out our degree, how many zeros we're supposed to have, the type that we're working with, the number of turning points. I'm going to go EB for end behavior. All right. So let's take a look. Don't think about zeros, because you can see here's a real one. Here's another real one. If you had said we have 2 zeros, which means it's a quadratic, you are completely wrong. A quadratic does not have that many turning points. We would only have 1. So you can see we have 1 turning point, another turning point, and a third turning point, which makes it a 4th degree with 4 zeros. Now you can see that we only have 2 real, which means the other 2 then have to be imaginary. We don't have any doubles. Right? So that was pretty quick. Now let's take a look. You can see both my end behaviors are going to be increasing. So it doesn't matter if x goes to positive or negative infinity, my y values are going up. This means my a value is positive. All right, so that's just by looking at a picture. We can do the exact same thing with an equation. So I'm going to go x to the fifth plus x to the fourth minus x cubed minus 7x squared plus x plus 30. We're going to identify all the same things. All right, so now what we're doing is we're working with just the equation. Don't have the picture anymore. I don't need the picture. I can identify degree. I can identify zeros. We're going to try and see if we can work with the type, turning points, and then of course our end behavior. We're going to work with all that stuff. If you need to pause, take a pause. Right? But degree should be easy. I see the largest exponent. I can't identify the turning points right now off of the picture. If I have a picture, identify turning points. Turning points is going to help you identify degree. Well, this one, you have the degree. Identify that first, which means I have 5 zeros, which means I have 4 turning points. Now, here's the kicker. I don't know what my zeros are going to be. I don't know if we have 1 real, if I have 2 real, 3 real, 4. I don't know about that. I don't know how many imaginaries we have. Right, maybe we have 4 imaginaries and 1 real. I'm not 100% sure about that. So this one we can't do. I'm going to go NA. The only way we'd be able to find out the type of zeros that we're actually working with is if we had a picture. No picture, not going to worry about that. Now, our end behavior. It is odd. So now we got to determine, well, what is happening based off of this? Now, since it is odd, but your a value right here is positive, that means my right side is increasing while my left side decreases. So on my negative infinity side, I'm going to negative infinity, and on my positive infinity side, I'm going to positive infinity. So that's what my end behavior would look like. All right, so that's just based off of your equation. Just by looking at it, not even trying to solve it, just looking at it, seeing what we can identify. So the only thing that we couldn't get was our types. Once again, pause if you need to. All right, almost done. 2 more things. Now we're going to look at a table of values, and then based off of the table of values, we're going to determine something called the intermediate value theorem. All right, so I'm going to draw a table, and I want to see if we can identify what we actually have now. So create a table of values, x, and then remember f of x is just your output. All right. I'm going to go from -3 to +3. I drew one too many. All right, I'm going to put in some x values or some y values here as well. All right. Now, we're still going to see, can we identify our degree? Can we identify our zeros? Can we identify the type? Can we identify turning points? And then, of course, can we also get in our end behavior, our EB? All right. Now, definition of a zero. It's a value that makes your function 0. So that means you'd be looking for zeros with your y values. But if you look, -47, 1, 5, 1, 1, -7, -59, I don't have any zeros there. So right now, a lot of people would say, we don't have any. Well, they're mistaken. I'm going to highlight these specific areas. And I'm really just looking at those y values. Main reason, the y values change signs. That is big. That is big news. That's big and important news. you always want to think about how the heck do you go from a negative y value to a positive y value. If I had a little picture, here's a negative y value. Here's a positive y value. If I want to go there, I have to pass through this value 0. Or if I went from a positive to a negative y value, I went down, I have to pass through 0. It's just, that's how numbers work. Negatives to positives, you're passing through 0. Positives to negatives, you're passing through 0. So that means right in between negative 3 and negative 2 is a 0. And in between 1 and 2, there is another 0. You just don't know what that 0 is. You can't be 100% sure. You can make a guess, but I don't really care about that. So based off of just this information, looking at our picture, I would say it's a degree of 2 with 2 zeros. There's 2 real zeros. I know for a fact they're real because they're somewhere in there. And that means I have 1 turning point. All right, so it looks like we have a degree of 2. The thing is, this is only a small section of values. There could be a heck of a lot more zeros. There could be imaginary zeros. So this is just a guess with us. Whenever I give you a table of values, you're not going to be 100% positive. We do know that at least in this case, it's a degree of 2. Maybe I have some imaginaries, but that just makes it more and more even. So instead of degree 2, we can make it degree 4, degree 6, or degree 8 with a bunch of imaginaries. And the reason that happens is because imaginaries always come in pairs. All right. Now the one thing that we also want to look at is our end behavior. Since it's even, we do know that our end behavior needs to be going in the same direction. So now what we just need to figure out, well, are my y values increasing or decreasing? And as you can see, as I move along the positive x values or the negative x values, I go further and further negative. So I'm going to go to negative infinity on both ends, which means that my a value is going to be negative in this case. And the reason I'm getting this is because I went from 5 to 1 to negative 47. That's negative infinity. I'm going 1, negative 7, negative 59. That is also negative infinity. That's how I'm getting that. I'm basing my end behavior off of what's happening with those y values. All right. Now, this leads us into our intermediate value theorem. If you want to be able to have a 0, your y values have to go from positive to negative or from negative to positive. All right? And that's the last part, our intermediate value theorem. So the definition says a function is defined by f of x which means it exists. Now, we're going to pick 2 values. I'm going to say if a and b and b are real numbers, so negative 2 or 7 or whatever the heck they are, and f of a and f of b are opposite in signs. Now remember, f of a just means I evaluated my function at that a value, and f of b is I evaluated that function at that b value. So maybe a was negative 2 and b was 7. I plugged in negative 2, I plugged in 7, I got some y values on return. And basically it's saying that your y values are going to be opposite in signs. Now if your y values are opposite in signs, then there exists at least one real 0 between A and B. I'll show you how this works in an example. But basically it's saying you got these two x values. When you plug in these two x values, you look at your y values. Did your y values change signs? Well, if they change signs, negative to positive, you went through zero. A zero exists, and at least one. There could be multiple, there could be more. You never know, your zeros could be really, really tightly compacted, but there's going to be at least one of them. All right, so an example, I'm going to put a function up here, f of x is equal to x cubed minus 2x squared minus x plus 1. And we want to show that there's a zero between x equals 2 and x equals 3. I could have written this as that, 2, 3. Not including 2, not including 3. So all you're going to do is you're going to evaluate at f of 2, you end up getting negative 1. You're going to evaluate at f of 3, and you're going to get positive 7. Now you can see the y values change signs. A zero exists. That's it. That's what I would want you to do. Hey, here's this function. Here's these x values that I want you to evaluate. Show me that there's a zero somewhere in between negative 2 and 3. I went from a negative number to a positive number. That means I went from 2.2 to 2.1 or 2.2 or 2.3. Maybe my zero occurs at 2.3. But it's going to occur somewhere in between 2 and 3. Right? So that's our homework, or that's our notes. Basic information, basic characteristics of graphs of polynomials. If we're ever going to graph them, hey, plug them in your calculator, plot points, get that off your tables, your table function. It's simple as that, but I just wanted you to know some characteristics. All right, so what you're going to be doing for homework, this is already assigned up on Schoology, but on page 342, not 343, on page 342, you're going to look at number 1 through 8, 21 through 27 odd, 43 through 47 odd, and then 61 and 62. You can also work on IXL. Of course, we're still in Algebra 2. You can work, these are still in our K functions. You can go K9, K11, and K14. K14 would be good. That's basically off of your functions. That's off of your polynomials, matching them up. So take a look at that stuff. Any questions, bring them back to me on Wednesday. All right.